Hi again, welcome to the second video about solving simultaneous equations in algebra. In this video we extend our use of the graphical methods we described in the first video to developing basic algebraic techniques for obtaining solutions to situations where we have been given uncomplicated relationships involving two variables. The two contexts discussed in this video are very much interrelated. In mathematics, we often have two or more activities happening at the same time in a given context. For example, a business has to assess the cost of the goods and services it requires, as well as its income. As patterns or behaviours can be modelled using equations, which is really one of the main purposes for doing maths in the first place, we can address problems within such situations. In the business case, we might want to know where our costs are balanced by the income. Beyond that point, we make a profit, which makes the whole effort worthwhile and more enjoyable. Mathematically, what we are doing is to take two or more equations and solve them together, that is, simultaneously, to find out what values of the variables meet both conditions specified by the equations. And we refer to this approach as solving equations simultaneously. Often the equations are linear, but this is not necessary. We can have one or both equations non-linear. For example, they could be circles, parabolas or something, and we will look at those in another video. In many questions, we are just given two equations and asked to solve them simultaneously. In such cases, the context is hidden, but we know that the equations would tell a story about a particular situation if they were allowed to. So the first format we look at is where both equations are expressed in terms of one variable, say y equals, and they have 1 as the coefficient of y. So we might be given, for example, y equals 3x and y equals x plus 8. Now this looks familiar because it's the situation we've had when we were looking for a break-even point. So there is a y term in both equations and they're equal so that we can equate the right-hand terms. So we simply write 3x equals x plus 8, 2x equals 8, x equals 4. Substitute the 4 into the first equation. We have y is equal to 3 times 4, which is 12. So x equals 4 and y equals 12 are the solutions. Now we can draw those two lines on a graph, the orange one being the y equals x plus 8, the green y equals 3x. Notice the first equation starts at 8 on the y-axis and goes up from there, whereas the other one starts at the origin. And when we look at the point of intersection and go across to the y-axis and down to the x-axis, we can see that our point of intersection is 4 and 12, just like we got algebraically. So the solutions are the point at which the two lines intersect on the graph. Now the second format is where we have one variable in one or both of the equations having a 1 as its coefficient. So here we've got two equations and the first equation has a 1 in front of the x. So that's the format we're looking for. Now step 1 in terms of solving these is to rewrite the equation having the variable with a coefficient of 1 to make that term as the subject. So we're looking at the x, we'll take the 3y across to the other side, so we're left with x equals 13 minus 3y. Now we take that equation in step 2 and substitute for that variable in the other equations and solve it. So we take the x, put it in, so we have 2 outside of 13 minus 3y in brackets plus the 5y equals 21. Tidy that up, you have minus y equals 21 minus 26, which is minus 5, so y equals 5. Then we use that y equals 5 to find the value of the second variable, i.e. x, and report both values. So when y is equal to 5, substitute into our modified first equation, which is 13 minus 3 times 5, so we have x is equal to minus 2. So we report both of the values in a separate line, x equals minus 2 and y equals 5. Nice and straightforward. These are good and probably represent about 60-70% of the questions that you're going to do. So always look for that coefficient of 1. Now the third format is a little bit like the first format, but here it's more generalised. So one variable has the same coefficient in both equations, and that coefficient could be 2, 3, or at least other than 1 to distinguish it. So in this case, the x coefficient in both equations is 2. So we can remove the x terms by subtracting one equation from the other. When the signs are different, we're going to add the equations to remove the common term. So here we'll do equation 1 minus equation 2. So we have 2x minus 2x, which is gone. 3y minus y, which is 4y, and 7 minus 5 is 2. So 4y equals 2, y equals a half. Substitute back into one of the equations, let's say equation 1. So we have 2x plus 3 times a half equals 7. 2x therefore is equal to 11 over 2, x is equal to 11 over 4, so we rewrite the joint solution of x equals 11 over 4 and y equals a half. So, what do you notice about this pair of equations? Correct. Both equations have a term in 6y, but the two terms have different signs. So if we're going to eliminate the y, we can eliminate it by adding the two equations together. Last time we just subtracted. So add together, 3x plus 2x is 5x, y's cancel out, equals 10, x equals 2. Substituting the value of 2 into the first equation, we have 3 times 2 is 6 plus 6y equals 3. 6y equals minus 3, y equals minus a half. And again, as we should always do, repeat your solution, so x equals 2 and y equals minus a half. Nice for your teacher, nice for the examiner. So in summary, solving equations simultaneously requires strategies to merge the two equations. And in this case, we've dealt with a few different formats. The first one was equations are written with the same variable as the subject in both equations. So the technique we're going to use there is to equate the other two sides and solve. The next format was where one equation had a 1 as the coefficient of one variable. And here we rewrite the equation to make the variable with the coefficient of 1 the subject of that equation, and then we substitute for that variable into the second equation. And the last one was where we had the same coefficient for one variable in both equations. Here we add or subtract according to the signs to eliminate the variable, and then we solve and substitute. So now you have the steps to solve a pair of simultaneous equations algebraically when they have uncomplicated coefficients like 1, or the coefficients of one variable are equal across the two equations. Hope you understand the approach more now. Thanks for watching this video. In the next video in the Simultaneous Equations series, we look at algebraic methods for pairs of equations where all the coefficients are different. Hit the like button and subscribe if you haven't already. Also go and do some questions in simultaneous equations with easygoing coefficients in Test Yourself 1 on my website at drjaysmaths.com. Add a comment below and send me an email if you have any questions. Good luck. See you later.